Dear students, welcome back. In last lecture, we have seen the introductory part of wave-particle duality, in which we have seen the basic difference between classical and quantum mechanics. Also, we have seen that our universe is made up of two things. One is matter and other one is the energy. And we know that energy has dual nature, that is wave nature as well as particle nature. Then the question came in the mind of de Broglie, and he had put one hypothesis that if our universe is made up of two things, one is matter and second one is the energy, and if energy possesses or shows dual nature, then why should not matter also possesses dual nature? And regarding same, he had put on a hypothesis. That hypothesis is called as Louis de Broglie hypothesis. So according to de Broglie, a particle of mass m moving with velocity v has a wave associated with it, and this wave is called as de Broglie wave, or is called as matter wave. Further to this, he had given wavelength of matter wave also, and according to de Broglie, wavelength of matter wave, that is lambda, which is equal to h upon m into v, where h is called as Planck's constant and m into v is called as momentum. Also in last lecture we have seen the basic support de Broglie has taken to put this hypothesis. Now in this lecture we are going to focus only on this equation. That is, we are going to focus on mathematical part of the de Broglie. He had given a very important three equation regarding matter wave, and we are going to focus, or we are going to see in detail that three equations. Now first start with lambda is equal to h upon mv. Actually from here he had taken the wavelength of matter wave, which is equal to h upon mv, or what is the support he had taken to put that mathematical equation. Now the first equation is de Broglie wavelength by analogy with radiations. He has taken the concept of photon to put that wavelength lambda is equal to h upon mv. We know that Einstein's mass energy relation is E is equal to m into c square, so we'll call this as equation number 1. Also we know that the energy of photon is E is equal to h nu, so we'll call this as equation number 2. So from these two equations, so E is equal to mc square and E is equal to h nu. So if you compare these two equations, we'll get h nu is equal to m into c square. H nu is equal to m into c square. Now we know that frequency is equal to velocity upon wavelength. So if we put the value of frequency or the equation of frequency here, then we are getting h as it is. Instead of nu we have to put c by lambda here, so c by lambda, and mc square will be as it is. So from this equation c gets cancelled, so we are getting h upon lambda is equal to m into c. So from this equation we are getting lambda is equal to h divided by m into c, where h is the Planck's constant and m is the mass and c is the velocity. So actually this is the photon concept, and if this equation is true for photon, we can apply this equation for other particles according to de Broglie. So similarly for other particles, for example for electrons, lambda is equal to h upon m into v, where m is the mass of the particle and v is the velocity. So this is very important equation, equation number or equation A, de Broglie has given by taking the support of Einstein's mass energy relation and photon concept. Now we are going to move to the second equation that de Broglie has given. De Broglie has given one more equation, that is which is related to wavelength in terms of kinetic energy of the particle. Now the question is that why he had given this equation or de Broglie wavelength in terms of kinetic energy? Because if you apply this concept, de Broglie concept, for electron, and when electron is in a motion, it has kinetic energy. So generally total energy of electron is always kinetic energy. So that's why, keeping this concept in the mind, de Broglie has given wavelength in terms of kinetic energy. Now we know that kinetic energy of particle is E is equal to half m into v square, where m is the mass and v is the velocity. Now if we divide and multiply by m here, so here it becomes m square divided by twice m. So what you have to do, you have to divide and multiply by m here, and m into v is momentum, so m square into v square is nothing but p square, because p is equal to m into v, so p square goes to m square v square, and if you put value of p square here, then we are getting E is equal to 1 upon twice m into p square. Now we have de Broglie concepts. From de Broglie concept we have lambda is equal to h upon p. So already we have got value of p square here, m square v square. So from this equation we are getting p is equal to root of twice me, and lambda is equal to h upon p. So just what you have to do, you have to put the value of p in this equation. So we are getting lambda is equal to h upon root of twice me, where h is the Planck's constant. To is the constant, m is the mass of the particle, and E is the energy, and that energy is kinetic energy. So this is one more equation de Broglie has given in terms of kinetic energy. De Broglie had given one more equation also. That equation is de Broglie wavelength in terms of applied potential. Again the question is that why he had given wavelength in terms of applied potential. The thing is that when we have to put electron in a motion, we have to apply some potential, and when you apply some potential, electron will be set into the motion, and that energy is kinetic energy. Now when we apply potential phi to any electron, then energy gained by that electron will be EV, and that EV is always kinetic energy, where V is the applied potential, E is the charge, and that speed or that energy is called as kinetic energy, and that kinetic energy is given by E is equal to half mv square. Again we are going to do the same thing that we have done in the previous equation. So here EV is equal to half mv square, so we are going to multiply and divide by m, so we are getting EV as it is, and here divide and multiply by m, so it becomes twice m, again m square v square, and we know that m square v square is p square, because p is equal to m into v, so we are getting p square is equal to m square into v square. So EV is equal to 1 upon twice m into p square. So from this equation we are getting p square is equal to twice m E into v. So we are getting p is equal to root of twice m EV. Again de Broglie wavelength is lambda is equal to h upon p. So just we are going to put the value of p here. So we are getting lambda is equal to h upon root of twice m EV, where v is the applied potential. Now if you see this equation, in that equation h is the Planck's constant, m is the mass of the particle, E is the charge, and v is the applied potential. Now our aim is to find out de Broglie wavelength in terms of applied potential, means we are going to find out equation between lambda and v. So lambda is equal to h upon root of twice me, where m is the mass of the particle, and if you apply this concept for electron, then for electron, mass of the electron is 9.1 into 10 to the power minus 31 of kg, charge of the electron is 1.6 into 10 to the power minus 19 coulomb, h is Planck's constant, which is 6.63 into 10 to the power minus 34 joule second, and if you put all these constant in this above equation, we are getting lambda is equal to 12.27 divided by root of v, that much angstrom in it. So this is one of the important equation which gives us relation between lambda and applied potential, where v is the applied potential. So in summary, we can say that there are three important equations given by de Broglie. First one is lambda is equal to h upon mv, this is called as wavelength of matter wave, this is equation number A. Second, in terms of kinetic energy, lambda is equal to h upon root of twice me, where E is the kinetic energy, that is equation number B. And third equation, lambda in terms of applied potential, lambda is equal to 12.27 divided by root of v, that much angstrom in it. So these are the important three equations given by de Broglie. So this is all about mathematical part of de Broglie. Thank you.